We also in last video already. Once again we will recap this one. So we got this y cap equal to g of 1 plus 3x1 2x2 in the map 1 here, this one 3x1 1 2 3 3x1 minus 2x2 minus 2x2 minus x2, so 2x2. Here 1 1, here 3x1, here 1, then 2x2. So that's it again. Y cap equal to g of 1 plus 3x1 minus 2x2. Now we are changing here minus 1 plus 2, that is this value. Assume minus 1 2, then y cap equal to g of 1 plus 3 x1 equal to minus 1 and 2 x2, this is x1, this is x2. Okay. Then 2 here, 2 here, minus 1, multiply, what will come? 3 into minus 1 3, 2 into plus 2 4, 4 minus 4 minus 3 7, minus 7 plus 1 minus 6, 0 minus 6, so approximately 0.002 here will come. Y cap 1 plus g of 1 plus 3x1 minus 2x2 in this graph. Z is less than 0, y is less than 0.5. Here this portion, and then this portion z equal to greater than 0, y is greater than 0.5. Here y, this is x1 x2, z is less than 0, here y is less than 0.5, here z is greater than 0, this portion, y greater than 0.5. building neural networks with the perceptrons. The perceptron simplified y gap equal to g of w naught plus x transpose w. Y gap we already know output, target output. G nonlinear, w naught weight, x transpose bias value, w the whole things w, so the whole things x transpose, not this one, not this one. This is bias. Okay. X, this one. Okay. Sorry. The perceptron simplified. 1 y equal to g of z simplified. So this is y z, this is g function, so z. Okay. Z equal to w naught, here w naught will go, w naught plus summation of j equal to 1 equal to m, 1 2 up to m, xj xj jth jth, sorry, it will not come here, here it is will come jth, it will change now 1 after 2 after m up to m, so it means here x1 w1, okay. 1, then multi-output perceptron, because all inputs are tensely connected to all outputs, all inputs tensely connected to all outputs, this is the tensely. These layers are called tense layer. This is the tense layer. Here input is, this is the output is, okay, connected to all outputs. These layers are called tense layers, okay. Zj, Z tie, W naught, here weightage will come, W naught, comma I, plus from jth to, for example, you can mention j here also, jth to 1, 2, m, all are will come under j, up to m, xj, okay, wj, this one, wj, both are multiplication. We will take here this one, this value, then plus addition, summation, this is to be multiplication corresponding. Dense layer from scratch, tensor layer from scratch. That layer from scratch. What is a scratch? Class my tensor layer tf dot keras dot layers dot layer. Tensor layer, my tensor layer, tf TensorFlow, keras also library, layers, that layer form. Layer form. Okay. Definition. Allah will start in the TensorFlow. You will start with only the definition. Start with the definition. Okay. So initialize def underscore initialize underscore of self input underscore deep output dimension. Input dimension, output dimension, self. Super. Into my tensor layer and the self, comma self, and the initialize of open and close bracket. Initialize weights and bias. Self dot w, self dot this is a w. Okay. We also initialize the variable. That one also variable with the w. Self add weight. Here also self add weight. Input dimension, output dimension. Here 1 comma output dimension. Def call self inputs. Forward propagate the inputs. Z equal to TF dot matrix multiplication of inputs self dot W plus self dot B. B is also same like W only. That one also one parameter like weight. Feed through a non-linear activation. Output equal to TF dot math dot sigmoid. Already we have seen sigmoid in mathematical function. This output we are expecting in sigmoid, not in tangent or not in other way. RELU. Return output. Multi-output perceptron. Multi-output perceptron means output, one output, two output. Y1 output, Y2 output. That's a multi-output perceptron. Because all inputs tensely connected means here, x1, x2 connected to z1, x2 connected to z2, xm connected to z1, xm connected to z2. This is called nothing but tensely connected to all outputs. These layers are called tensor layers. Outputs. This one. You can say this one outputs. Outputs. Processing. Zi equal to. You can say Zi. So this one. Z1, Z2. If we calculate Z1, Z1. Here is Z1. Here is Z1. If you are calculating Z2, here is Z2 will come. Here I substitute Z2 here also. W not I, comma I plus summation of j equal to 1 to m xj wj comma I. Import. What we are going to import? TensorFlow. How?